Okay, we're going to use the initial rates method to figure out the rate law for a reaction. Remember, the rate law tells us how the rate or speed of a reaction is related to the concentrations of reactants. And in the initial rates method, we figure out, we do a experiment multiple times. Each time we change the reactant concentrations, like done here, and we figure out what happens to that initial rate. The initial rate is the speed of the reaction at the very beginning. All right, the initial rates method has these 5 steps, so we'll go through them together. All right, so the first thing we have to do is we start off with our reaction. We only care about the reactants, so I don't even care about the products. Okay, so step 1 is to write out a generic rate law. We know that the generic rate law is going to be the rate equals K times the concentration of ClO2 raised to some power m times the concentration of OH minus raised to some power n. And we're going to try to figure out m and n, and then finally K. All right, so step 2. Step 2, we go ahead and we use our 3 trials to figure out, to rewrite this. So 0.0248 equals K times 0.06 to the M times 0.03 to the N. Our second trial, so this was our first trial, our second trial was 0.00276 equals K times 0.02 . Right? Notice we changed the concentration for ClO2, but we kept OH minus the same. So by looking at these two, we'll be able to tell the effect of M. So we can get M out of that. All right, our third one is 0.00828 equals K times 0.02 to the M times 0.09. All right, so here we kept the M's constant, or the concentration of ClO2 constant, but we changed the concentration of OH minus. So we can use these two to find N. Okay, so let's go ahead and look at this. So step 3A, right? We're going to try to find M and N. We can do it in either order, but let's start with M. We're going to use number 1 and number 2. And the key is we want to put the one that's faster, that has a bigger rate, at the top. So I'm going to do 1 over 2. This half doesn't come into play. This is just an indication so I can know that. All right, so I have this written down, and now I go ahead and I look at that, and I say what cancels out. The k's cancel out, and this last term cancels out. So now I have 0.0248 divided by 0.00276. It's going to get me 8.99 equals, this is going to be 0.06 over 0.02 to the power of m, or 3 over m, 3 to the m. Now, I can tell right away what m is. But let's go through the steps, right? Remember what we said. M can either be 0, 1, or 2, right? It can be more things, but in this class, you usually see those. All right, so if I had 3 to the 0, that will get me 1. If I have 3 to the 1, that will get me 3. If I have 3 to the 2, that will get me 9, right? Because 3 squared is 3 times 3. All right, so what does that mean my m is? My m's not 1, or my m's not 0. It's not 1, it's 2. So m equals 2. Right? Notice 9, 8.99, those are close enough. I can say m is 2. All right, so I just found out that my m is 2. Now let's move on to step 3b. 3b, we just found out what m is. Now let's go ahead and find out what n is. And so I'm going to use number 2 and number 3. I'm going to put the faster than 2 up. Which one's faster? The one that's faster is the one that has the bigger rate. Okay? So this will be 3 over 2. Okay? Now, I could use other ones. I could do 3 and 1, but 3 and 2 is nice because I kept these two constant, or whoever did this experiment. All right, so I take my values for the rates, put those on top of each other, and then I put the other side. Be very careful because sometimes we make mistakes, right, in transposing these. It's very common. So all right, notice I kept it just as m. I could have put it as 2. In this case, it doesn't matter because no matter what, these two things are going to cancel out. Right? The k's are also going to cancel out. And so I end up with this divided by this. So that's 3 equals 0.09 the n over 0.03 the n, or 3 equals 3 to the n. N is equal to 1, right? Because n, 3 to the 1 will give me 3. Okay, so now I know what n is, and I know what m is, and so now I can go ahead and I can plug these in, right? So after 3, I get that rate equals k times ClO2 squared times OH minus. Notice how I don't include the 1 there, because that one's redundant and it's just not needed. All right, now I can go ahead and I can solve for k. Which one do I use to solve for k? I can use any of the 3. In fact, I'm going to do 2 of them right now just to show that it doesn't matter. All right, so let's rearrange this. I get k equals rate over ClO2 squared times OH minus. Okay, we're going to rearrange a lot. Make sure you know how to do that. So if I do number 1, that would be 0.0248 over 0.06 squared times 0.03. It's going to get me 229.6. I can do the same thing for 2. 0.0276 over 0.02 squared, 0.03. Here I get 230. And let's actually do the last one. That's 0.00828. Make sure you include that squared because that's important. I get 230. All right, notice this one's a little bit off. By the way, in the problem, as stated on the screen, you can see it has 2 sig figs, so this is actually 230 because that has 2 sig figs. So the fact that I get the same answer for both of them, or very, very, very close, means that I did it right. Let's just show what happened if I did it wrong, right? Let's say I said that this m was equal to 1. So I said k equals rate over ClO2 times OH minus, right? In this case, if I plug these in, 0.0248 over 0.06 and 0.03, what do I get? $13.7 or 13.8, right? And if I do that for trial 2, trial 1, trial 2, what do I get? I get 4.6, right? I get different values for k. Remember what k is. K is a rate constant, so it should be the same. So this, if I get different values for the k, that's a sign that I messed up, okay? All right, but we got the same, so we're good. So that's step 4. We found out it's 230. Step 5 is units, okay? So now I do the same thing, except I look at just the units. So k equals molarity seconds minus 1. That's what the rate is in. Over, this is molarity squared. This is molarity. That's molarity square. Molarity second to the minus 1 over molarity cubed. That's going to get me molarity to the minus 2 seconds. So that is my units for my k. All right. So I went ahead and I answered what my rate law is and what the value for that rate constant. All right, let's just show it on the screen. We start with a generic rate law. We plug everything in, and then we can find m, n, and then I go ahead, I solve for my value for k, and then finally the units. All right, initial rates method is tough. It takes some practice, so make sure you get that practice in before the homework and then also before the next quiz and test. All right, talk to you later.